practice test here, number 11. All right, this one, we've got the approval rating. All right, we've got a president. His rating, basically, if you're for a president, you've got to be over 50%. What they do is they conduct, you've got the local paper, and it conducts a poll of 100 randomly selected adults. All right. Then we've got some big group here, and they conduct a poll over 1,010 randomly selected adults. Okay. Which poll is more likely to report that the president's approval rating is below 50%, assuming that this is his actual approval rating? Okay. Well, in this case, you've got two different samples. You've got 100 as a sample, and you've got 1,010 as a sample. Okay. The rule of thumb is the larger the sample, the nearer you are to true. Like true proportion. In this case, the 54%. Okay? So this one, the smaller sample is more likely to be below 50%. Okay? The smaller the sample, the more variability. Okay? What I mean by more variability, it means that it could be really high, it could be really low. You don't have that many people, so it could get swayed one way or the other. Okay? All right, number 12. All right, you've got a box of cereal. It has an average of 13 ounces. It's got a standard deviation of 0.5 ounces. That is like the population. Okay? Then what happens is we get we sample some. Okay? We've got a case of 12 cereal boxes, and it's got 160 ounces. Okay. Well, the first thing you need to make sure that you do is that you have yourself this normal model. Okay? In the middle is going to be your 13. Okay? This is a sample of means. All right, well, the sample mean equals the population mean, which is 13 ounces. Okay, so that's a given. Now, the standard deviation of the sample equals the population standard deviation divided by the square root of n. So it's going to be 0.5 divided by the square root of 12, which in this case equals, all right, I have to get my calculator out here. 0.05 divided by square root of 12, and you get 0.014, okay? So 0.14434. We'll kind of go out pretty far, all right? Okay, the next thing you want to do is that's our standard deviation. Well, we want to know what we've got here is we've got 12 cereal boxes of more than 160. So I need a number, I need a sample number. Take 160 and divide it by 12, okay? And what you get then is you get 13.33. That's going here. We want to see if it's more than that, so we're looking for this p-value, okay? So you're going to go to your calculator, and you're just going to do normal CDF, okay? Here we go. That's in second distributions. You're going to do CDF, it's cumulative, okay? Your lower in this case is 13.33. All right? Your upper is, I don't know, 10,000. Your mean is 13. Your standard deviation is going to be this one that we found. It's going to be 0.14434. Okay? And you figure that out, and we get so it is approximately 1.1%. Okay? That is the probability that you have a case of 12 cereal boxes contains more than 160 ounces. All right? Okay. 13. Here we go. Got a random sample. You got 150 men. Found that 88 of the men exercise regularly. Random sample of 200 women. Found that 130 of the women exercise regularly. 2 samples. This is a 2 proportion. Based on the results, construct and interpret a 95% confidence interval for the difference in the proportions of women and men who exercise regularly. First things first, in order to construct a confidence interval, we need to make sure that this is normal, and we can't go on with normal until we can check the conditions. Okay? Conditions. All right, so we start with randomization. And basically, we are told, we are told it is random. Or it's a random sample. Okay? The next one is our 10% condition. And in the 10% condition, basically 150 is less than 10% of men. 200 is less than 10% of women. And the next one is our independence. And we basically can say randomization ensures independence. Okay, the next one is our success failure condition. And basically what that means is you're going to have to do that twice for each one. You take this number right here, say 88 greater than or equal to 10, and then you go on and you say, what's that? What is it? 62 is greater than or equal to 10. And then you go to the other one and you say, okay, 130 greater than or equal to 10, and 70 is greater than or equal to 10. All right. So these are at least 10, and so you may continue. All right. So now with these satisfied, we may proceed with as a normal model. Okay, and we're going to do a 2 proportion Z interval. All right, I can go ahead and use my calculator. All right, I don't have to do all of that. Okay, you should probably write down that the confidence interval equals, and then you might say the P men minus the P women plus or minus the margin of error. Okay, and it's not too necessary. We're going to do a 95% confidence interval, so we need to know that Z equals 1 point, on a 95, let's see, what does my Z equal? 1.96, okay? I'm going to go ahead and use my calculator. I'm going to go to my stat. I'm going to go to tests, and it is a 2 proportion Z interval, okay? Right here, you have 88 as X1, N1 is 150, X2 130, N2 200, confidence level 35. I'm going to calculate it, and this is what we get. Our confidence interval is a negative 0.1662 and a 0.03952. You could also write it as a negative 16.62% and a 4 point, yeah, well, you could say a 3.9. You could go a 3.95%. Okay, so you could do it that way. Then we need to state our conclusion. We need to say we are 95% confident the proportion of women who probably exercise less than men is 4% to then, this is probably a little awkward, 16.6% higher than men who exercise. Okay, if it's negative, that means that the women exercise 16% more. Positive means that the men exercise 4% more. Okay, that's what that means. A friend says she believes the higher proportion of women than men exercise regularly. Does this confidence interval support the conclusion? Well, you kind of look at it, and you've got here 16% and only 4% of men higher, and so you kind of look at that and you wonder to yourself and you think, well, maybe this person has, that she's right, because 0% means they exercise the same. All right? And because 0 is in our confidence interval, we do not have enough evidence to support this conclusion. You might think, negative 16 is a lot lower than this little 4, and the 0 is more toward the upper. But the point of the matter is, because 0 is in this confidence interval, we do not have enough evidence to support the conclusion. Everything would have to be negative in order for you to say, yes, we support this conclusion, okay? But because 0's in there, we cannot support it. All right. Internet access. All right. You've got a poll. 28% of teens have a computer with internet access in the room. Poll was based on a random sample of 1,028 teens. Margin of error, 3%. What level of confidence did the Gallup poll use? If we're talking level of confidence, we need to find my Z number. All right? Margin of error, go back to that formula, and it's Z times the square root of PQ over N. Hey, we have all the numbers we need. The margin of error, 0.03. We do not know the Z. That's because that's what we're looking for. All right? We know that P, success, 0.28. Failure, 0.72. Total number of people, 1,028. Do a little algebra. 0.03 divided by the square root of this. And that will get you your Z. Okay? Take out your calculator. All right? And let's see what we get. I'm going to do alpha y equals. That makes it a little bit easier when you're doing it. Okay, 0.03. Down below, I'm going to do square root. Let's do another alpha y equals in that. And we'll say 0.28 times 0.72. And down below, 1,028. And we end up with 2.14. So 2.14 equals the Z. That does not tell us the level of confidence. But what that does mean is that if I have a normal curve with 0 in the middle, I've got 2.14 here. Okay? And I want to know that number there. I want to know what percent that is, where I am at. I could use the back of the book, or I can use normal CDF. Okay? And in order to use normal CDF, I am going to go up to second distributions. There it is. My lower limit is super negative. Okay? My upper limit is 2.14. My mean is 0. My standard deviation is 1. And I get 0.98. So 0.984. So it is 98.4%. Okay? And that's what it is. Now, oh, wait a minute. If the Z is there, I still have to do this one. Hang on. So it's going to have to be, sorry, you're going to have to take that number, point right there, and subtract from it another normal CDF from that to a negative 0.218, okay? So then subtract it, and you get point there is that's the answer, okay? So then it's basically 0.984 minus that part right there, okay? And you are going to get 0.967 or 96.7%, okay? All right, last one. Here you go. This one, you've got to do the entire hypothesis test. It says, test the appropriate hypothesis. State your conclusions, all right? You need to do all your conditions, okay? You have to make sure that that all of them hold true. It's a random sample. It's a Gallup poll, so we're going to assume randomness, and you would go down the line for that, okay? All your conclusions. All right, your null hypothesis is going to be that 50% get enough sleep. Okay, that's it. Now, the poll said that it was 55%. So that's our alternate, that P is greater than 0.5. Okay? This is a one proportion Z test. All right? And so we are looking on your calculator. Okay, you'd have to find out, we need a standard deviation. Remember, our standard deviation is PQ over N. But if you go to one proportion test on here, one proportion Z test, okay? The null hypothesis is that it's 0.5 X. Here, 55%, and then there were that many adults. So you have to take 1,003 times 0.55, all right? Now, I don't know what that is. Oh, shoot, that's going to be a decimal. So I'm going to have to quit out of here real quick. And I'm going to say 1,003 times 0.55. And I can't write a decimal, so I'm going to say 552. Okay, so what I do, now I go back to my test again. And I've got in there, so I'm going to say 552. N is 1,003. Now, it's going to be this one right here because we're saying it's greater than. And our p-value, 7.14 times 10 to the negative 4, which equals, don't forget this E there. People forget that. 0.123714. Okay? So then you would say, with such a small p-value, we reject the null hypothesis. There is strong evidence that the proportion of U.S. adults who feel they get, and you just need to reiterate what it says up here, enough sleep is more than 50%. Again, that's my null. I'm rejecting it, kind of going with the alternate at this point. Okay? All righty.